Hello and welcome back to the course on deep natural language processing. And today we're going to look at end-to-end deep learning models. And the reason why we're delving into this area is it will help us understand why sequence-to-sequence models are actually so good, because sequence-to-sequence models are a type of end-to-end deep learning models. Okay, so let's have a look. So here we have our diagram on the right. We've got the natural language processing, the deep learning, the deep natural language processing, and the sequence-to-sequence in the middle. Then we're going to look at a specific example, a specific use case of natural language processing. Let's say this is us, and we want to contact a customer support center of a company that we have bought a product or service from. For example, let's say we have a mobile phone and something's not working. We don't have enough internet on our phone, or they sent us a excessively high bill, or we want to find out some information about roaming overseas because we're about to travel. And so what we normally do is we call them up and we talk to the customer support representative, like we can see here. The customer support representative uses their mind to come up to assess our problem and come up with a solution. And more often than not, they can solve a problem. Of course, sometimes we're frustrated because there is no solution to a problem, or we didn't get the answer that we wanted, or the charges on the bill are actually valid, and so on. But that's not the problem that we're looking here. The problem we're looking here is the problem of communication. And that's this part. Did we get our message across? Did they understand the message? Did they apply some sort of model, in this case the brain model, to come up with a solution to help us out? This is what we're worried about. So in this case, none of this is anywhere in this diagram. This whole concept, I love it. This whole concept is actually way outside the diagram, because it's a human being talking to a human being over the phone. There's no natural language processing. There is probably here in the brain, but that's not what we're concerned with. We can't construct the brain. We're here to construct machine learning, deep learning, AI, chatbots, and so on. So in this case, we're way out of the diagram. As you can see, result is great. Mission accomplished. Okay. Then what happens, or what happened in history? So this is going to be like a little excursus into history, so you can sit back and relax and grab your cup of coffee or tea or whatever you're drinking and enjoy. So what happened after that? After that, companies started being smart, started cutting costs and replacing and increasing efficiency, to be fair, and replacing their support representatives with automated systems. And we've all been through this, when you call up and all of a sudden, instead with your favorite company, and all of a sudden, instead of a person on the other side, you hear this voice, which is like a human but a pre-recorded voice saying, "Hello, welcome to this company and XYZ company, and please listen to the following options carefully, as the options may have changed. For our sales department, press 1. For our marketing or for our customer support, press 2. For billing, press 3. To check your account balance, press 4. And for all other questions, press 5. Something like that. So I hope I acted out that quite well. So we would use the dial pad. We'll have to use the dial pad to tell this system where we want to go. And this might sound familiar from what we discussed previously. This is one of those heuristical if else, if this then that, if that then this type of algorithms, where you keep pressing the buttons, and sometimes you get somewhere if your query is quite easy, you want to check your account balance. You press the buttons and it gets you there. But a lot of the time we have very specific queries in mind that don't get solved through a decision tree or through a flow chart like that. And what happens is, well, actually, let's first of all place it on the map. So on our map, this is a natural language processing algorithm. As you can see, without deep learning, that's over here. But basically what happens in these cases, we've all been there. we get really frustrated and nothing happens because it's not that we're frustrated because the bill is too high and it is truly like that, or because they don't have a roaming option. We're frustrated because of the communication issue. That's the part that's frustrating. We cannot get our point across. This thing does not understand us. And once again, I'm sure we've all had experiences like that. So what happened next? Well, or what's happening now? We're actually getting very close to the present. What's happening now is, again, same situation. We don't have a person on the other side of the phone, but now all of a sudden we can talk to the lady, or the man on the other side, the robot voice. And how does that happen? Well, as we call them, they say, "Hey, welcome to company X, Y, and Z. Please tell me what you're calling about." Have you had that in your life? Have you had a situation like that? I've definitely had a couple of those where you call up and it asks you to actually tell them in your human voice what they're talking about, what you're calling up about. And why is this possible? Well, this could be possible for a couple of reasons. So I'm going to put a brain here. I'm going to go go all the way and put the brain here. It could be possible due to, remember we talked about natural language processing, but with audio waveforms. It could be done through audio waveforms, and it could analyze the audio waveforms and then understand what you're saying. But I'm going to go the extra mile and just going to put the brain here because some companies are already going, I hope that some companies are already going into this new way of voice recognition. And in this case, the voice recognition is with deep learning. So it's using deep learning to understand what you're saying, to understand your query, and that's great. That's a step forward. That's a step in the right direction. But the problem is we're still sitting here on the border. And why are we sitting on the border? Because even though it allows you to say things in a human voice instead of using the dial pad, it still then passes your result into the flowchart, into this decision tree. And it's like pretty much the same thing as you would use a dial pad, except for sometimes it doesn't recognize you well, especially if they're not using deep learning, if using like one of those frequency dissection or analysis algorithms from just NLP side of things, then this is going to be terrible because they're going to get the wrong thing in the first place and then they'll pass the wrong thing on here. But if they're even getting the right thing, it's still passing on to a decision tree, and it's very limited in the options that it has, just the predefined options that they've thought about, that list of things. And so result, again, frustration. The communication did not go through. But as you can see, we're making our way into the right direction. Next one is, what happened next? Oh, by the way, like after this, you may have noticed, like I've noticed companies that went down this path and they got even more frustrated customers than in the previous one where they had the dial pad, and so they reverted back to the dial pad. So it was really interesting. One time I called up my mobile phone provider, and instead of a dial pad, they were like, "Please tell me what you're calling about." And the experience was even worse. And then a couple of months later, I called them up again. It was a dial pad, or maybe I was part of a pilot test or something like that. But yeah, so some companies see this as even a more of a challenge. And of course, you're going into the more advanced areas of computer science, into the more advanced areas of natural language processing. It is going to be challenging. Anyway, so what happened after that, or what is happening now, is now again we can talk with, again, it depends on the company, the region, the I don't know, like the service, I guess, that you're using. But there are, I hope there are advanced companies where you can talk, and what they use in the background is deep learning algorithm as before, but this time it's different. This time they also use a deep learning algorithm to analyze your what exactly you're saying. So there's a deep learning algorithm trained to analyze your sound forms that you're making with your vocal cords, and then there's another deep learning algorithm that is trained to take that information. Let's say it's in text form. It's like being converted into text or something, or machine format, and this algorithm is trained to understand the meaning. So this algorithm just basically transcribes your voice, your audio that you're producing into words, and then this algorithm takes the words, understands the meaning, and searches for the answer that you're looking for and supplies you that, or directs your call to the right person, and so on. Basically, it tries to solve your problem. So now we're fully in the deep natural language processing, and this is the part where we're about to celebrate. Everything's amazing, but what we get is, again, we get frustration. How does that happen? How come again it didn't work out? And this is the key to where we're going. The key is always being on the screen up here, my friends, at the top. End-to-end deep learning models. The problem with this approach is that you have two separate deep learning models. And this is a very simplistic example. There can be other applications of deep learning, deep natural language processing, where you could have not just 2 steps of deep learning, but you could have 3, 4, 5 different steps, and each one could be converted into a deep learning model. Just because deep learning is so versatile. But the problem is, the problem occurs if we keep them separate as separate deep learning algorithms. The thing there is that this one goes through training on its own, this one goes through training on its own, and therefore there's a misconnect. It doesn't flow. It's not like one algorithm that is taking care of the whole thing of understanding what you're saying, transcribing it, finding the meaning of what you're saying. Like not even just like transcribing it, but finding like taking your words, processing them internally, finding the meaning, and coming up with the answer. So as soon as you have like 2 or more, because the training happens separately, you will run into problems. Not necessarily all the time, but a lot of cases have been reported, or many cases have been recorded of this happening, that because the deep learning algorithms are separate, you run into problems. Think of it like, the best way, I guess, to imagine it, because we're talking about intuition here, and it's hard to come up with a concrete this is why it went wrong. It'll be case by case. But the best way to think about it is like, imagine 2 humans. Like, one human is transcribing what is being said. The other human is searching for the answer. Like taking that, understanding the meaning, searching for the answer. And it becomes one of those cases, like, that game where you have to come up to the next person in the like in front of you and whisper into their ear what you heard from the person behind, and you do that a couple of times and meaning is lost. Similar thing here. Again, it's a far-fetched example, but that's kind of the concept. Because they've been trained separately, this one's very good at what it does, this one's very good at what it does, but together it's not very good at what it does overall. So that's the best way I can describe it here. So basically, that's why we need end-to-end deep learning, so that one brain is taking care of the whole thing. And that is the next stage, the next step, or some might say the final step, the final frontier that we have to look at. And it would look something like this. So you talk, there's a brain, and there's an answer. So it's very similar to that part where we had the human. Remember, we had the human over here and the human brain, and we had the answer. Similar, we're getting there slowly. And the reason why this is so cool is because there's this part in this deep learning circle, there's this part called the end-to-end deep learning models. And that's where we're putting our new model. And notice it's not necessarily in sequence to sequence. I specifically purposefully put it somewhere between, because it could be sequence to sequence, could be some other model. This end-to-end deep learning models part is quite vague. It's not very defined. It's not like an area that you can say these are end-to-end deep learning, like this. They're characterized by this, and this. It's just a way of somebody saying that, look, my deep learning model actually, it's just one neural network that takes care of the whole thing. Like, I've built a neural network from start to finish, or more or less from start to finish. And therefore, it's kind of just it's a term that's used quite loosely to express that, but that's the concept, that there's one neural network running the whole show. And if you have something like that, then you have more chances of it being successful and delivering a great customer experience in this case, and in other cases there's of course other applications. So there we go, that's what end-to-end deep learning models are, and as you can see, sequence to sequence luckily is an end-to-end deep learning model, and that's what we're going to explore further down in this course. And I look forward to seeing you next time. Until then, happy analyzing.